When people think about modern warfare, they usually imagine weapons, soldiers, and battlefields.
But the infrastructure behind today's conflicts looks very different.
Military operations now rely on cloud computing, artificial intelligence, satellite networks, and vast streams of real-time data.
And much of that infrastructure isn't owned by governments.
It's operated by some of the most powerful technology companies in the world.
In this deep dive, we explore how Silicon Valley quietly became part of the modern military-industrial system.
And why the next generation of warfare may depend less on weapons.
And more on the platforms that power the digital world.
Okay, let's unpack this. War has essentially entered the cloud.
It really has.
When you look back at how global conflicts were sustained in the 20th century, the foundation of military power was heavily industrial. I mean, it was completely physical.
Right. Totally geographically constrained.
Exactly. The determining factors were your steel mills, your shipyard capacity, complex petroleum supply chains, and mechanized manufacturing. You basically won by outproducing the adversary on physical assembly lines.
Yeah, and that legacy model was highly visible. You could see the factories. But today's strategic engine operates completely in the background. It's out of sight.
Just humming away in server farms.
Precisely. We are looking at hyperscale data centers, machine learning algorithms, low Earth orbit satellite constellations, and, real-time data fusion. But the defining characteristic of this new era isn't merely the technical capability.
No, it's the jarring reality of who actually owns the underlying hardware.
Exactly.
It's a massive paradigm shift away from state ownership. It isn't the Pentagon or the Ministry of Defense building this stuff anymore. It is private technology companies.
Yep.
The exact same corporate entities hosting enterprise software, processing global financial transactions, routing your everyday internet traffic. They are now the foundational pillars of international military operations.
It's a wild shift.
It is. And think about that for a second as you're listening right now. How much of your personal data sits on the exact same server farm that is currently processing active targeting telemetry for a drone strike?
It's definitely something that gives you pause.
I really want you to drop your thoughts in the comments below on this because it fundamentally changes how you look at the tech ecosystem you interact with every single day.
Well, to understand how we arrived at this structural dependency, we have to look at the collapse of government-led innovation.
Right.
Historically, defense organizations, they developed bespoke technology from scratch. They laid the groundwork for the early internet, they built the GPS network, they pioneered early mainframes.
The space race, all that.
Exactly. But that model completely fractured in the 21st century. The private sector simply achieved escape velocity.
Yeah.
I mean, the sheer volume of capital poured into commercial research and development by big tech completely eclipses even the largest defense budgets.
But wait, defense departments still have astronomical multi-billion-dollar procurement budgets. Why couldn't they just hire the top engineering talent and build their own closed-loop systems?
Because it's not just about the money. It's about the speed of iteration. Government procurement cycles take years.
Well, sometimes decades.
Right, decades to finalize requirements for a single piece of hardware. Meanwhile, Silicon Valley is pushing software updates multiple times a day. Militaries realized that trying to build their own proprietary cloud or AI infrastructure would mean deploying technology that was already obsolete on day one.
So they had no choice.
They had no choice but to adapt and integrate commercial platforms. This created what our sources refer to as the new military backbone, and it rests on 4 critical pillars.
Okay, lay those out for us.
First, global cloud architecture operating at hyperscale. Second, AI for rapid intelligence processing. Third, space-based networks for resilient connectivity. And fourth, real-time edge computing for operational support.
Meaning war is no longer fought with kinetic weapons alone. It's fundamentally an information processing contest.
Exactly.
You could deploy a multi-million-dollar 5th-generation stealth fighter, but if its encrypted data link drops, or the server farm processing its threat matrix goes offline, you don't have an apex predator anymore. You just have a very expensive blind piece of titanium flying in circles.
That's the reality. So let's examine the specific players providing this infrastructure, starting with Microsoft.
Okay.
Through their Azure government cloud, they have quietly positioned themselves as one of the largest digital infrastructure providers for global defense organizations.
We're talking about transitioning entire intelligence databases and classified workloads into cloud environments maintained by a commercial vendor. That's huge.
It's massive, and it goes far beyond static data storage. Azure is providing the secure computing backbone for active battlefield information systems. They're running massive, persistent digital twins.
Like highly detailed virtual replicas of real-world environments.
Right, for wargaming and simulation. But more importantly, they enable real-time, cross-domain intelligence sharing. A naval group can seamlessly share targeting data with ground forces and allied nations in milliseconds using containerized workloads at the tactical edge.
Which eliminates those old bureaucratic silos where intelligence agencies couldn't even talk to each other because their proprietary systems weren't interoperable.
Precisely. In modern conflict, cloud capacity equals operational speed.
Wow.
The faster a military can ingest, analyze, and distribute classified data securely, the faster they can maneuver. In contemporary warfare, latency gets people killed.
That makes perfect sense. And Microsoft isn't the only giant in the room. Amazon Web Services, or AWS, is providing massive chunks of this global architecture too, specifically taking over the logistics and supply chain systems.
AWS is fundamentally the data and logistics engine of the modern internet. Militaries recognize that the microservices architecture Amazon uses to track global shipping routes or optimize distribution hubs and process millions of consumer transactions, it translates flawlessly to military logistics.
Because moving artillery shells is conceptually similar to moving retail inventory.
Exactly.
But doesn't that introduce a massive, glaring security flaw? If a military is running its supply chain on AWS, aren't they sharing server space with thousands of civilian applications that state-sponsored hackers are already constantly trying to breach?
It's a valid concern, but it's handled through highly specialized architecture. Commercial providers build isolated environments, like AWS GovCloud, which are physically and logically segregated. They use virtual private clouds and stringent cryptographic air gapping. What this means is a military gets the infinite scalability of commercial cloud computing without having to build a physical data center in a war zone.
So they can spin up a network anywhere.
Right. They can deploy a scalable command center with the computing power of a supercomputer in a matter of minutes.
Here's where it gets really interesting. We have all this infinitely scalable storage and edge computing, but what are they actually processing? This brings us to what the sources label the data challenge, and how Google's architecture fits into the picture.
The modern battlespace generates an incomprehensible ocean of unstructured data. We are talking about petabytes of intelligence, surveillance, and reconnaissance, or ISR data. High-definition drone feeds streaming continuously.
It's fire hose.
It is. Satellite synthetic aperture radar sweeping entire continents, ground sensors detecting electronic emissions, endless streams of intercepted communications. The bottleneck in modern war isn't gathering the intelligence, it's processing it.
Because you can't just throw 10,000 human analysts in a basement and ask them to watch thousands of hours of drone footage simultaneously. It's physically impossible.
Exactly. And that is where machine learning models step in as the ultimate filtration system. Leveraging the kind of neural networks and pattern recognition Google pioneered, militaries use algorithms to detect anomalies instantly.
Right.
A machine vision model can scan a terabyte of satellite imagery in seconds and flag a camouflaged surface-to-air missile battery that a human analyst would have easily missed in the noise.
So it's an algorithmically assisted battlefield. You aren't replacing the human commander. You're just handing them the needle without making them dig through the haystack.
But the evolution doesn't stop at basic computer vision and pattern recognition. We're currently witnessing a massive transition from data filtering to true cognitive capability. This brings us to organizations like Anthropic and the introduction of frontier AI into national security frameworks.
Frontier AI. Referring to those highly advanced large language models that demonstrate complex reasoning and emergent capabilities.
Yes. What's fascinating here is that we are moving beyond algorithms that just identify a tank in a photo. Advanced frontier models are now being integrated as strategic partners in operational planning. They're capable of reasoning across highly disparate, complex data sets.
You're giving a commander a digital staff officer that can cross-reference 1 million pages of adversary military doctrine with real-time intercepted communications in 3 seconds.
And then applying threat modeling to that data. Imagine a scenario where a frontier model analyzes global supply chain manifests, spots a sudden spike in a specific precursor chemical being shipped to an adversary's port, cross-references that with recent intercepted radio chatter about weapons testing.
And instantly simulates 5 probable scenarios for what the adversary is building and where they'll deploy it.
Exactly. It provides predictive operational assistance based on a global web of context no human team could hold in their heads at once.
But for an AI to actually reason across all that geopolitical context, the data has to be standardized. If the drone video is in one proprietary database, the satellite imagery is in a different format, and the intercepted communications are in a completely separate network, the AI is just staring at a wall of chaotic noise.
That is the problem of siloed intelligence, and it is the exact friction point Palantir was built to solve. Palantir specializes in data fusion. They take highly disparate, previously incompatible streams of raw intelligence and seamlessly integrate them into a unified ontology.
Let's picture what that actually looks like in practice. Imagine a 60-second window during an active deployment. A friendly convoy is moving through a valley. A commercial satellite detects a faint thermal anomaly 3 miles ahead.
Okay.
Simultaneously, a drone captures a brief glint of metal in the dust, and a signals intelligence unit intercepts a 2-second burst of encrypted radio chatter.
Separately, those 3 data points mean nothing. The thermal anomaly could be a generator, the glint could be trash, the radio burst could be routine.
Right.
But Palantir's platform fuses those disparate data points instantly. It recognizes the pattern, identifies the high probability of an impending ambush, and pushes a real-time alert directly to the convoy commander's digital dashboard.
Wow.
It turns fragmented noise into predictive intelligence. War increasingly runs on these data fusion platforms, making the software arguably more vital than the armored vehicles themselves.
But all of this real-time data fusion is totally useless if the commander's dashboard loses connection. You can't run a cloud-based war on fiber optic cables that get severed by an artillery shell on day 1. How are they guaranteeing the data actually moves?
They rely on the orbital connectivity layer. In active conflict zones, traditional infrastructure like cell towers and hardlines are the first assets targeted. To maintain that crucial link, you need a robust, low-Earth orbit satellite constellation.
Ah, space.
Yes. This is where private space companies, most notably SpaceX with its Starlink network, have completely altered the strategic landscape.
Because they provide a mesh network in space that can't be taken out by a single localized strike.
If we connect this to the bigger picture, the reliance on commercial space infrastructure represents a structural vulnerability. In the past, military space assets were exclusively built by defense contractors, launched by state agencies, and operated securely from military bases.
Not anymore.
Today, militaries depend on high-bandwidth, low-latency commercial networks to coordinate drones, share intelligence, and maintain basic command and control.
They are essentially leasing their most critical communication arteries from private billionaires.
It creates an unprecedented geopolitical dynamic.
It really does. If you're finding these insights as mind-blowing as we are, make sure you subscribe to our YouTube NC Web Dev channel right now. We have so much new stuff coming out, and you will not want to miss it.
Returning to that dynamic, this reliance perfectly illustrates a deeper fundamental shift, the massive commercialization of military infrastructure. We've moved from bespoke, state-owned systems to platforms that simultaneously serve everyday consumers, enterprise businesses, and global militaries.
It's crazy to think about. A server rack processing a highly classified threat matrix for an intelligence agency might literally be sitting in the same physical facility as a server processing credit card transactions for a grocery store chain.
The boundary between civilian technology and military capability has been structurally erased by dependency. This wasn't necessarily a deliberate policy choice either. It was an inevitable outcome of scale. The immense computational power, speed, and efficiency required by modern algorithms can only be achieved by leveraging massive, globally distributed commercial networks.
Which opens up a terrifying legal and ethical gray area.
This raises an important question. Who actually dictates policy when critical infrastructure is commercially owned during a global conflict? Governments are now heavily dependent on multinational corporations that have competing obligations, global shareholder pressure, and customer bases spread across hostile borders.
It puts the tech executives in the position of acting as shadow diplomats or unofficial defense secretaries. What happens when a private company decides they don't agree with how a military is using their cloud architecture?
The frameworks for accountability, liability, and ultimate authority are completely unresolved. If an AI reasoning model provided by a commercial vendor hallucinates or makes an analytical error that leads to a catastrophic friendly fire incident, where does the legal liability fall?
Does it fall on the battlefield commander who trusted the dashboard?
Or the software engineer who trained the model, the CEO of the tech company? States are only just beginning to grapple with the immense vulnerabilities of relying on digital supply chains they do not legally own or unilaterally control.
Let me throw this out to you listening right now. How should a private tech company handle a global conflict involving its users? Should they pick a side and cut off access to the adversary? Or should they remain completely neutral infrastructure providers, like a utility company? Drop your debates in the comments below, because I guarantee you the boardrooms in Silicon Valley are sweating over these exact scenarios right now.
All of this points to a total redefinition of the military-industrial complex. We're stepping into an expanded ecosystem. The old ecosystem was dominated by traditional prime contractors, the legacy aerospace and defense companies bending metal to build tanks, fighter jets, and aircraft carriers.
The Lockheed Martins and the Raytheons of the world.
They're still crucial, but the expanded ecosystem now includes hyperscale cloud providers, frontier AI labs, data analytics firms, and commercial space companies as Tier 1 defense contractors. This new digital industrial base was initially designed to sell targeted advertisements, stream media, deliver next-day packages, and connect people on social networks.
Yeah.
Yet it has organically become the central nervous system of global security.
So what does this all mean for the future of warfare?
The trajectory is clear. Artificial intelligence will continue to accelerate the decision-making cycle, moving from just analyzing data to autonomously recommending physical actions. We're going to see a sharp increase in autonomous systems operating with significantly reduced human-in-the-loop oversight. Space-based connectivity will become the most guarded strategic resource on the planet, and global computing infrastructure will solidify its position as the ultimate battlefield terrain.
The source material refers to this interconnected architecture as the new stack of modern warfare. It's no longer a collection of disparate tools. It functions as a single massive organism.
Let's break down the 3 layers of that stack. At the apex, you have the AI and cloud layer. This handles the heavy computational lifting, the predictive modeling, the strategic reasoning, and the on-demand edge compute services.
Okay.
Beneath that is the data platforms layer, acting as the logic engine that aggregates, cleanses, and fuses raw operational intelligence. And at the foundation is the core connectivity layer, consisting of the low Earth orbit satellite constellations and mesh networks that actually push this data out to the tactical edge.
The most glaring takeaway here is the absolute fragile interdependence of the whole stack.
Yes. Each layer is entirely beholden to the others. Take out the connectivity layer, and the multi-billion-dollar AI models are starved of data. Compromise the cloud layer, and the AI cannot run its algorithms.
Right.
Disrupt the data platforms, and the incoming intelligence reverts to disorganized noise. If you pull out any single Jenga block, the entire digital nervous system degrades.
To really wrap our heads around this transformation, we just have to look at the foundational materials of power. The 20th century was built on steel, industrial production facilities, complex oil logistics, and mass manufacturing capacity.
And the 21st century is built on hyperscale cloud systems, unified data platforms, frontier algorithms, and commercial satellite networks.
Modern conflict is no longer just a clash of physical weapons. It is a clash of technology infrastructures. And that infrastructure was built by and remains completely dependent upon private tech companies operating on a global scale.
Which leaves us navigating a radically transformed geopolitical landscape, where the traditional boundaries separating civilian enterprise from national security have effectively vanished.
And it leaves you with a final thought we haven't explicitly covered, but one you really need to ponder. If military superpowers are now entirely reliant on commercial civilian infrastructure,
does a targeted cyber attack on a civilian data center or an AI server farm suddenly constitute a profound act of war?
and if so, does that make every single civilian tech worker maintaining those servers an unwitting frontline participant in global conflicts?
It is an incredibly sobering reality to consider.
Think about that as you go about your day. Remember to leave your thoughts and your debates in the comments below. Thank you for joining us on this deep dive.